All right, welcome ladies and gentlemen to section 3.5, the first of two videos to go along with this. The first video here, we're going to deal with tangent and cotangent together, and the second, we're going to deal with cosecant and secant. So we're going to look at these two graphs separately, or these two functions separately. So let's go ahead and look at just some general things first. Both the tangent and the cotangent have the period of pi. And so this is a very big note that you make sure you understand. For tangent and cotangent, in order to find the period, you must use pi over b, not 2 pi over b as we did before with sine and cosine. And the function looks just like this. You can replace tangent with cotangent. The a, b, c, and d all basically have the same effect as they did with the sine and cosine functions. The only slight difference is the way the function looks. There is technically no amplitude, but a still does a vertical stretch or shrink on the function itself. So let's go ahead and look at tangent, the parent function itself. So if you take a look here, the period for tangent is pi. The range is all real numbers. And in fact, it kind of looks like a cubic, as you'll see here in a few minutes. The domain of this function is x cannot be. X is going to be everything except for pi halves and every multiple of pi afterwards. And so this in pi, that represents every multiple of pi. And the reason that is because at each of those values, there's an asymptote for tangent. And if you think about it, the tangent of pi halves on your circle is y over x, and the x coordinate is 0. So everywhere there's an x coordinate of 0, tangent becomes undefined, and undefined on a graph means asymptotes. And lastly here, the symmetry for tangent is odd. We're going to go to the next page here to graph the function. And I started off with a full 2 pi a pi in each direction. And what we're going to do here is we're going to look at really kind of the values that you would find on your table or on your circle. If you went to use just the values on my graph, you wouldn't actually find enough stuff here. So what we're going to do is we're going to add in pi fourths. Because earlier I said tangent can't be anything. It's an asymptote at pi halves and every pi away. So at both of my pi halves, I'm going to have asymptotes. But let's verify that. Let's go to negative pi halves first. We're going to go negative pi fourths. We're going to go 0, pi fourths, and pi halves. And if you go to your unit circle and you find that the tangent of pi halves, by the way, this is tangent, that's what we're doing here. Should be obvious. Tangent of negative pi halves is, well, that's tangent of 270, and that's undefined. And undefined, obviously we're going to say UND, gets a vertical asymptote. And then at negative pi fourth, the tangent of negative pi fourths is negative 1. The tangent of 0 is 0. The tangent of pi fourths is positive 1. And the tangent of pi halves is also undefined. So if you're following that 5-point method, notice the 5 values that I use here. And that's going to come up on the next slide. So over here, I'm going to put in my other asymptote at pi halves. And I'm going to put in the other dots that I know. So I know the point 0, 0. I know the point pi fourths, or negative pi fourths, negative 1. Positive pi fourths, positive 1. And now comes the point of trying to graph this. Now this is going to kind of look like a cubic function. It does follow the same kind of curve, and it comes down here and it starts to follow my asymptote in each direction. Now, the larger you make your scaling, a little bit harder to make your graph. You notice it's a little hard for me to draw the curve to touch the dots as I go down, but it really should cross through that point. So this is the parent function. I can continue this on as far as I want. If I go to pi, notice, remember the period for tangent is pi. So from 0 to pi, I have to have the same value. This is 3 pi fourths, so this value has to be down here. And I can hopefully connect dots, which I don't do a very good job on this, as I've mentioned. Here at negative pi, and that negative pi fourths there, or 3 pi fourths, it's going to come up here like this. Okay, so that is 2 full periods of tangent. Half up and half down makes 1 full period, right? And really, between negative pi halves and positive pi halves is 1 full period, 1 full cycle, if you call it that, of tangent. So I'm going to mention here the 5-point method for tangent. I'm not going to mention it for cotangent, but we're going to use the same kind of idea here. We're going to let the bx plus c be those 5 values that I chose to use on my table from the last page. And just like with sine and cosine, you're going to solve for the new x value. You're going to substitute that x into the equation and solve for the corresponding y value, and you're going to get, this table of new values, right? You're not going to use negative pi halves, pi negative blah, blah, blah up here. You're going to use your new x values. You're going to plug them in and get the new y values. Okay, I'm not going to do a particular problem like this. I'm going to do kind of the faster method, my method here. And we're going to look at this particular function here. So we need to pick out our pieces. For the period is pi over b, and in this case b is 2, so it's pi over 2. So my period is now pi halves. I'm going to do a center line of y equals -1. Now this is not exactly the same because we don't really center everything on this line, but it does tell me that I'd go down 1 unit. And my amplitude is 1, and that really affects the pi fourths value from the parent function, whether or not it goes up 1 or it goes up 2 or up 3 or whatever a is. And there's no phase shift on this particular function, so there's no horizontal shift, so I don't have to worry about that. Now, for tangent, if you recall, you should because it wasn't that long ago, the parent function looks like this. It really does look like a cubic function, except for it has vertical asymptotes. Because it goes through the point 0, 0, that is the point that you must move first. So since the period is pi halves, there's no horizontal shift, but there is a vertical shift. Instead of going through 0, 0, I'm going to go down 1, and it's going to start here. And what I've done is I've done the center of 1 period, which means I need to go half the period this way, and I need to go half the period this way in order to find my 2 asymptotes. Well, since my period is pi halves, I need to come this direction pi fourths, and I need to go this direction pi fourths around my center. And what that does is it finds my 2 asymptotes, because the distance between 2 asymptotes is 1 period. I will draw that right here. The distance between this is 1 period between 2 asymptotes. Then, because my amplitude is 1, halfway to my asymptote, on the right, it goes up normally, and on the left, it goes down normally. And again, that depends on whether or not it's a positive value or a negative value. And you get to draw your tangent function like so. And that would be the tangent of 2x minus 1. It's been shifted down 1 unit, and it has been vertically or horizontally shrunk. Because now the period is only pi halves instead of pi. Okay, let's look at another one here. So we've got a lot more stuff going on here, but nothing we can't do. Here we have amplitude of 3. We'll just keep calling it center of y equals -3. It creates a center line, even though we don't actually draw a center line like we did for sine and cosine. Means it's being shifted down 3 units. The period in this case, again, is pi over b. So in this case, it's pi halves again. But there is a phase shift, and it's still the same thing. It's c over b. So it's pi halves divided by 2, which is just pi fourths. So there's a pi fourths phase shift to the right because of the minus sign. So we can go to graph this. Now, because I need to go down 3 units, I don't need a whole lot of my upper quadrants, 1 and 2. Now, we're going to move pi fourths to the right. Now, we're going to move 3 down. So 1, 2, 3. My amplitude's 3, so I need to go down to 6. We're going to call this pi fourths. And so what this does now is, because I need to go, remember, tangent looks like this. I'm moving the 0, 0 point to do all of this stuff. So I'm going to go down 3 and right pi fourths. That's going to be my new center dot. And I need to go period of pi halves. So I need to go half the period to the right, and I need to go half the period to the left. Half that period is pi fourths. So that's 1 pi fourths, that's another pi fourths. So 1 pi fourths after is going to be pi halves. Now I didn't stretch out my graph very big, but that's not a huge deal. So here I have my 2 asymptotes equidistant from my center point, that phase shift. Then I can use my amplitude. Halfway between and halfway between. Halfway between here is what, pi eighths. Not super important for us, except for because my amplitude is 3, I need to go down to 6 or -6. And the amplitude up here goes to +3. And you'll notice the farther it gets stretched, the harder it is to draw a curved line. Please do not draw straight lines because these are not straight lines. They do curve. And do your best to draw a good curved line. All right, so you notice that all of the processes are basically the same. You do have to remember that the period for tangent and cotangent is found by doing pi over b. And always think about what does the parent function look like and moving that 0, 0 point first, then finding your asymptotes, then finding your other 2 dots. Now the process is the same for cotangent, only things get moved around just a little bit. So let's look again at the parent function for cotangent. Let's see on all these up here. All right, so the parent function for cotangent, the period is pi. Again, the range is all real numbers. And the domain, in this case, x can't be any multiple of pi because our asymptotes occur at every multiple of pi here. And again, if you think about it, on your unit circle, cotangent is the x over the y, and any place a y is 0 makes an undefined cotangent function. And again, with cotangent and tangent, it's an odd function, rotates evenly around the origin. So let's look at the graph of cotangent, the parent function, by the way. Now, in the 5-point method, which I don't specify in this in the next slide like I did for tangent, for cotangent, the numbers are 0, pi fourths, pi halves, 3 pi fourths, and pi. Those are your 5 values for the 5-point method. If I plug in 0, the cotangent of 0 has a y coordinate of 0, so therefore it is undefined on the unit circle. Cotangent of cotangent of pi fourths is 1. Cotangent of pi halves is 0. The cotangent of 3 pi fourths is -1, and the cotangent of pi is undefined. So you notice with tangent and cotangent, I like to start with an asymptote and end with an asymptote. So we're going to draw those in. So I have an asymptote at 0, and I have an asymptote at pi. Pay very close attention to the fact that the asymptote on the y-axis, that's the thing that we're going to be moving later on in our other examples. At pi halves, it is 0. And the halfway betweens, the pi fourths, is at +1 on the left and at -1 on the right. And it looks almost identical to tangent, except for it's upside down. Sorry, I'm missing my dots here. You get the idea. All right, so this is the parent function for cotangent. Again, I could continue this in both directions here. I could say we're up here, down here, and then I can connect going like this. This is 2 full periods of cotangent. All right, let's look at a couple examples here. In this one here, this is just a phase shift, so not a whole lot going on here. But let's just write it down in case we need it. Period is pi. Phase shift is pi fourths to the right. No vertical shift, and my amplitude is 1. So I'm not going to write that part down. All right, so my period is pi. I need to go pi fourths to the right. So if I call this pi fourths, I need to go pi fourths to the right. Well, what that does is, if you recall the parent function again, the y-axis is very important for us because the y-axis is the piece that I'm moving with my phase shift. So I'm moving the asymptote, and the asymptote needs to move pi fourths to the right. Then I need to go 1 full period to find my next asymptote. And my next asymptote has to be 1 pi away. So that's why I have 4 of these dashes, each of them worth pi fourths, which means this is 5 pi fourths because the distance between 5 pi fourths and 1 pi fourths is 4 pi fourths, which is 1 pi. Then, in the middle of those two asymptote is my 0. And then halfway between my 0 and my asymptote is this higher point. The other direction is a lower point. I could connect my dots as best as I can, which I can't do on this computer thing. But there you go. That is 1 full period of cotangent. If you felt like going the other direction, I would need 1, 2, 3, 4 more dashes going this direction. Another asymptote. Up, middle, down, and connect the dots. So remember, cotangent goes downwards and tangent goes upwards. All right, I have one more example for us to just kind of kick off here before we head out on this video. This one I've got a negative cotangent. So I have a period here of pi over, you have to remember that this is 1/3 here, pi over 1/3, which is 3 pi. I have no phase shift. I have an amplitude of 2, but I'm going to note that it's flipped. and I'm going to go down 2, or sorry, up 2. I don't know where that came from. Up 2. So my new center line is at y equals 2. So no phase shift, but I do have to go up 2. So creating my axes, I'm going to go a little bit up a little here. Now I'm going to go 1, 2, 3, 4 because I need to go up 2 and my amplitude is 2, so I better have at least 4 on here. And cotangent's not being shifted at all. And so my first asymptote is going to be at the y-axis. And my next asymptote has to be a full period away. So I can say this is 3 pi. And if I let each of these dashes be pi, I can create an asymptote at 3 pi. Halfway between is going to be my center dot moved up 2 units. Normally, cotangent goes in a downward slide, except for it's negative, so it's going to go upwards. So at pi, or sorry, halfway between, which is going to be 3/4 pi, it's going to be at the 0. And halfway in the other direction is going to be at my higher point, the 4. And we're going to connect our dots. Whoops. What's going on here? Sorry about that. Try that again. Okay, asymptote here. I'm assuming you have all the other stuff written down. Asymptote there. There's 4. There's 2. Halfway is going to be at the 2. Halfway here is going to be at the minimum. And halfway here is going to be at the 4. And connect the dots. Because it is a negative cotangent, it's going to look like a tangent. And there we have our graph. All right, I hope you learned quite a bit today with tangent and cotangent. The secant and cosecant video will be up shortly after this one. I will see you guys later.